Welcome everyone. Let's learn a new lesson and I hope that everyone is in the right track. So this is just a revisions of what we have learned in the previous chapter. So probability distribution can be divided into two. The first one you call it discrete probability distribution and the second one we call it continuous. So in the previous chapter we have discussed about the discrete probability distribution. So under discrete it can be divided into two. The first one you call it binomial distribution, while the second one we call it hypergeometric distribution, and the last one we call it Poisson distribution. So for today's lecture we will be focusing on the second part of probability distribution. We call it continuous distribution. Okay, so let's look at the overview of this chapter. So there are actually three types of continuous probability distribution. The first one we call it uniform distribution. The second is normal probability distribution. And the last one is exponential probability distribution. So in your syllabus, we will be only covering the second types of continuous probability distribution. So the remaining two will not be covered in your chapter. In this chapter, we will cover only a few learning objectives, so please ignore the first learning objective and the last learning objective. So in this part, you are expected to be able to describe the characteristics of normal probability distribution as well as approximate binomial probability distribution, and you should be able to compute or calculate their probabilities. Okay? Since we will not discuss about the uniform distribution, so please ignore this slide. So the slide for uniform distribution will start from slide number 4 until slide number 9. So make sure that you take note of this information. Please ignore this part as well because it is part of the uniform distribution. Ignore this as well. This one too, please ignore it. Ignore this as well. And the last slide should be ignored by you. Okay? The second types of continuous probability distribution is called as normal distribution. So for your information, we have three types of continuous distribution. The first one is uniform, which is not covered in our chapter. And the second one is normal. And the third one is exponential, which is also not covered in our syllabus. So let's look at the normal probability distribution. It is actually a continuous distribution with the following characteristics. So what are the characteristics of normal probability distribution? The first one, it is bell-shaped and has a single peak at the center of the distribution. So let's try to draw this distribution. So you have a bell-shaped curve, okay, and then you have a single peak at the center. So you should draw it at the center, okay. The second characteristics of this normal probability distribution is that the distribution is symmetric. So what is symmetric? Symmetric means you have a mirror image. So your left curve and your right curve should have the same shape. Okay? And the third one, it is asymptotic. Asymptotic means that the curve will approach the x-axis. Means that this is your curve. Okay? So it will kind of like approaching the x-axis. So this is your x-axis, but this curve will never touch your x-axis even though it is like approaching very closely to the x-axis. So when you draw a diagram, you know that your horizontal line refers to your x-axis while your vertical line is actually your y-axis. Okay, and the last one, it is completely described by its mean and standard deviation. I don't know where is my marker. Oh, it's here. So you should describe your curve using the mean and standard deviation. So in other words, if let's say you want to explain your curve, you will explain using your mean and standard deviation. Okay, next point. There is a family of normal probability distribution. So what is family? Family means that you're going to have different shapes of probability distribution. You can have this kind of shape and this kind of shape, and what else? Variety of shape. So whenever you have different mean or different standard deviation, you will have different families. It means that you're going to have different kinds of shape. Okay? This is your normal curve, which is perfectly or nicely drawn by this line. So your normal curve will have two tails, the first tail and the second tail. So your left tail will have a negative infinity values, while the right tail will have a positive infinity value. Okay, so when you have this kind of normal curve, you know that you will have a symmetrical distribution. Okay, so when you have a symmetrical distribution, your mean, median and mode should be in the middle. So everything should be equal. Okay, so another information about your normal curve is that the totals of this area, this whole thing, will give you the value of 1. Okay, so when we talk about half of this area, it will give you the value of 0.5. Another half of this area will give you the value of another 0.5. So in total, if you plus the left side and the right side, it will give you the value of 1. Remember, for the probability distribution, summations of all the probability will give you the value of 1. So it is also applicable for the continuous probability distribution. Okay? So let's look at the family of normal probability distribution. So the first family, how can you differentiate this family? Basically, these three diagrams have the same mean, which is 20 years. However, if you look at the shape, they have different shape. Shape is actually referring to your standard deviation. So the first diagram, you have the standard deviations of 3.1. The second diagram, you have 3.9, and the third one is 5. Because you have different standard deviation, that's why you have different shapes. How about the second family? If you look at this diagram, they look alike, right? Because their standard deviation are the same, 1.6, 1.6, and 1.6. But what differentiates them is their mean, the middle point, or we can say the center of their distribution are actually different. The first one is 200 plus, second is 301, and the third one is 321. Okay, so this is the same, or this is the second family. How about the third family? The third family, you can see they have different shape and different mean as well. So in conclusion, we can say when you have different mean or different standard deviation, so you have different types of family. Okay. Standard normal probability distribution has a mean of 0 and standard deviations of 1. If you want to draw a diagram, so basically the middle point is 0 and the standard deviation is equals to 1. If you want to compute standard normal probability distribution, you have to use this formula. Z equals to your x, your observation, minus your mu or your population mean over population standard deviation. We will look at the example in the next slide. Okay. Areas under the normal curve also refers to your probability as well as your likelihood. Okay, sometimes the question can ask you compute the areas under the normal curve, or it can also ask you compute the probability or likelihoods of something. So basically they are referring to the same thing. So you have to take notes of that. So let's try to apply the previous formula on standard normal probability distribution. So what is the formula? Z equals to x minus mu over standard deviation. So let's assume that you have computed your z and you got the value of 1.5. So if let's say you want to convert this 1.5 into the area under the normal curve, or you want to convert it into probability or likelihoods, you have to refer to the table. So this is the table, and you can see that you have z value here, right? You have many values. So let's see our z value. We got 1.5. So 1.5 is here. So what is the value? 0.4332. Okay, so this is your area under the normal curve. Okay, and you can also plot it in your diagram. And let's say you compute your z value, you got the value of 1.51. So what is your probability, or what is your area under the normal curve? So your probability is the next one, because you have 1.5 and then you got 1. So this is the 1. So the value for your probability is 0.4345. Okay, so please take note of that. So let's look at the examples of standard normal probability distribution. So there are many things to read here. Let me just go straight away to the question. Suppose the weekly incomes of Uber drivers follows the normal probability distribution. So when you read this question, it is clearly mentioned or clearly stated that you have to use normal probability distribution formula. And next, with a mean of 1000 and standard deviations of 100. So once you read all this information, it is better for you to list down everything so that you can easily plug in them into the formula. So what is the mean? The mean is equals to 1000 and standard deviation is equals to 100. Okay, next, what is the z-value of income for a driver who earns 1100? So what is this value 1100? If you still remember in the previous discussion, I always tell you that the x value will always be given in the question. So this is your x value. So you should write it here, x equals to 1100. Now, after having all this information, it's better for you, or it is very easy for you to plug in into the formula. What is the formula? Z equals to x minus mu divided with your standard deviation or sigma. So you should get the answer of 1. So the second question, what is the z value of income for a driver who earns 900? So now your x value has changed from 1100 into 900. So you can simply change the x into 900, and if let's say you plug it into the formula, you should get the value of -1. Okay, so far so good, right? So let me draw you a diagram, okay, so that it is easy for everyone to see it. Okay, this is your diagram. Okay, for your information, the diagram for standard normal probability distribution has two scale. The first scale you have x scale, the second scale you have z scale. Okay, so the middle value for your x scale, you have the mean. The mean is 1000, so you can write it here, 1000. While for the z value, the middle value is actually 0. Okay, so remember that. And then you have 1x here, which is 900. Okay, another 1x here, which is 1100. It is a bit smaller, but I hope that everyone can see it. Okay, so how about the z scale for 900? So you have computed it. You got -1. While for 1100, you got +1. Okay, so basically this is what you have computed. Okay, so what you have computed is the z value. Okay, so this is not even the area under the normal curve, or this is not even the probability or likelihood. Okay, so if you want to convert this one value or the z value into the probability or area under the likelihood, area under the curve, so you have to refer to your table. So basically, if you refer to the table, you will get the value equals to 0.3413. So basically, this value, this area will give you 0.3413, and this area will also give you 0.3413. Basically, you can just refer to your table. Okay, so let's try to check the formula of standard normal probability distribution with the empirical rule. Do you still remember what is empirical rule? It says that 68% of our observation should lie within ±1 standard deviation. And the next one, it says as well, 95% of the observation should lie within ±2 standard deviation. And it also says that 99.7% of our observation should lie within ±3 standard deviation. So let's try to check what the empirical rule says with our standard normal probability distribution. So let's try to verify the formula, okay, using the empirical rule. So using the standard normal probability distribution, we can say that z equals to 1 will give you the value of area under the curve, which is 0.3413, right? So if let's say we take into the value of plus and -1, so you have to multiply with 2, you should get the value 68.26. So if let's say you multiply with 100, so you should get the value of 68%. Let's try with the z value, which is equals to 2, and consider plus minus, so you have to multiply with 2. So you will get the answer of 95%. And if let's say we try with the z value equals to 3 and consider these two areas, plus minus, or both sides on the left curve and on the right curve, you should get the value of 99.7%. So basically what we got in empirical rule and what we got in standard normal probability distribution are actually the same answer. Okay, so this is the examples of empirical rule. I know that we have learned about empirical rule, but I never touched on the formula and how to compute the empirical rule. So what is the formula for empirical rule? The formula is mu plus minus k standard deviation. So what is this k? K can range into 3. The first one is 68%, second is 95%, and the third is 99.7%. If let's say the question mentioned about 68%, so your k is equals to 1. If 95, your k is 2. If let's say 99.7%, so your k is equals to 3. Now let's look at the question. Okay, there are many other things here. I will just go straight away to, for a particular D cell alkaline battery, the mean life is about 19 hours. So please write down here, mean equals to 19 hours. The useful life of the battery follows a normal distribution. So you know that you have to follow the normal distribution with the standard deviations of 1.2 hours. So your sigma here is 1.2. Okay, now, so what is the question? The first one, about 68%. So it is clearly mentioned here, 68%. So what is the value of your k? Your k should equals to 1. Okay, about 68% of the batteries fail between what two values? So let's try to apply this formula. Mu plus minus 1 standard deviation, because your k here is 1. So you have your mu, which is 9. Okay, let me write it here. Mu plus minus, because your question is 68, so k become 1 standard deviation, so your mu is 19, plus minus, so you will have a range, or you will have two values. So plus minus 1, what is standard deviation? 1.2. So this will give you the value of, because normally you have to start with negative, so 19 minus 1 multiply with 1.2, so you will get the value of 17.8, and then 19 plus 1 multiply with 1.2, so you should get the second value, which is 20.2. Okay, the next one is about 95%. So here your k will become 2. And the next one, virtually all of the batteries. So basically when you say virtually all, it refers to 99.7%, or we can also say mostly all. So basically you have to take the value of k equals to 3. Okay, now if let's say I want to draw a diagram, okay, how does it look like, right? So what is the middle point? Remember, mean is in the middle. What is your mean? 19. Okay, so let me write the second part. 1 standard deviation, right? So k is 1. So what is the value for 1 standard deviation? So you will get the value of 17.8. And another one here is 20.2. So these two areas will give you the value of 68%. You can also draw for 95% and 99.7%. So your diagram will look like this. Okay. This slide is the continuations of slide number 14 that talks about the incomes of Uber driver. So in slide number 14, the main important point is that your mu equals to 1000 and your standard deviation equals to 100. Given these two information, we should be able to answer these two questions. So what is the first question? The first one is, what is the probability of selecting Uber driver whose income is between 1000 and 1100? If let's say you want to convert this statement into the statistical form, you can write it this way: probability of weekly income which is bigger than 1000 and smaller than 1100. So if you want to answer the question for continuous probability distribution, it is best for you to draw a diagram, because we are talking about area under the curve. So you can see which area are we talking about. So you know that when you draw a diagram, you have two scale, the x scale and z scale. So what is the middle point for the x scale? Definitely your mean. What is your mean? Your mean is 1000. So for the z scale, the middle point is 0. Okay. Okay, now if you look at this question, you have 1000, which is your mean, and then you have 1100. Okay, so you can plot it 1100. So your question asks you, what is the probability of selecting the incomes between 1000 to 1100? So you want to find this area. When we talk about probability, basically you are asked to compute the area under the curve. You want to find this area. What is the value? So how to compute this area? You have to use the formula of standard normal probability distribution. So what is the formula? Z equals to x minus mu over standard deviation. So what is your x? You don't know, isn't it? Well, basically, as I mentioned in the previous discussion, the value for x is always given in the question. Okay, in this case, you have 2x, 1000 and 1100. So if let's say your x is 1000, you know that the middle point is 1000. Definitely, your z value will equals to 0, right? Because if let's say your x equals to 1000 and you minus your mu, which is also equal to 1000, definitely you should get 0. So you don't have to compute the first x value. How about the second value, the second x value? You got 1100 minus the mu. What is your mu? 1000 over, what is your sigma? 100. So this will give you the value of 1. Okay, so your z is equals to 1. Basically, this is not your probability. This is not your final answer. This is not even your area under the curve. So how to convert z equals to 1 into your probability? Definitely you have to refer to your z table, or we can say the table of area under the normal curve. So this is your table, and these are all your z value. So what is your z value? You compute, you got 1. So the probability is 0.3413. So basically you can say, well, your probability is 0.3413. So this area is actually equals to 0.3413. Okay, so you have finished question number 1. Let's look at question number 2. What is the likelihood, or what is the probability, or what is the area under the curve of selecting Uber driver who earn less than 1100? So it is best for you to draw another diagram so that you can see which area are we talking about. So what is the middle point? This is your mean, right? So you have x scale and z scale. So x scale is 1000, z scale is 0. Okay, so what is your x here? Your x is 1100. Okay, so 1100. So what else? So you know that you have computed this area, right? Just now, this will give you the value of 0.3413. Okay, so what is the question? What is the likelihood of selecting the incomes which is less than 1100? So you want to know, you don't want to know this area, you want to know the income which is less than 1000. This is 1100, right? So you want to know those who earn less than this. So basically you are talking about this area together with this area. You have two areas. So how to compute this? Okay, if you still remember, I mentioned to you in the previous slide. Okay, so your curve in total will give you the value of 1. If let's say we split your curve into 2, this part will give you 0.5. Another half of this will give you 0.5. Okay, now let's look at our question. So what is the value of this part? Definitely you have 0.5, and you have computed this small area, which is 0.3413. So the total is what? What will you get? You will get 0.8413. Okay, if let's say the question asks you, what is the likelihoods of selecting the Uber driver who earn more than 1,100? Now, the question is interested in this area. Okay, so if let's say I want to split your diagram, this half, okay, right? So you have computed this area, you got 0.3413, and the question is interested with this area. Can you compute this small area? Definitely yes, because half of this will give you 0.5, and then you have computed this area, and you have to minus 0.3413. Then you should get the value in this small area. Okay, so this is another questions on finding areas under the normal curve. So what is the question? If you look at here, the question asks you what is the probability of income of Uber driver between 790 to 1000. Okay, so as I mentioned previously, if let's say your mean is equals to 1000, you don't have to compute the second x here, because if you compute the second x, your z value will equals to 0. Just compute the first x. So what is the formula? The formula is here. Z equals to x minus mu over sigma. So your x is given in the question, which is 790, minus your mu, which is 1000, over your sigma. So you should get the value of negative 2.10. So when you look at here, the symbols of negative, it shows that the value should be on the left side of your diagram, like this. Okay, so this is your z value, negative 2.10. It is not even your probability. So how to convert this value into probability? So definitely you have to refer to your z table. So this is 2 and you have 2.1, right? So 2.1 is here. The value is actually 0.4821. So this is your answer. Means that if you want to plot it in the diagram, you will put it here. So you know that you have to draw a diagram, right? So you have two scale, z scale and x scale. So for the z scale, the middle is 0. For the x scale, the middle is your mean. And you can also plot your x, which is 790. And 790 will give you the value of your z equals to negative 2.10. And it will give you the area under the curve, which is 0.4821. Okay, so the next question, the second question, what is the probability of weekly income less than 790? Okay, so you have computed 790, and this question asks you less than this. So less than this is this small area. You want to know those who earn below than 790. So how to find this small area? As I mentioned to you, right? Half of this diagram will give you the value of 0.5. Since you have computed the first part, so you have to minus 0.4821. That will give you the remaining small area, which is 0.0179. Okay? This is also another examples on finding the area under the normal curve. Please try to do these 3 questions at home. Okay? Another question as well for finding the area under the curve. So please do it at home. Finding a value for your x using z value. So normally your x value will be given in the question. However, in this case, your x value is missing. So you have to use the formula of z to find the value of your x. So let's look at the question. Leighton Tire and Rubber Company wishes to set a minimum mileage guarantee on its new tire. Tests revealed that the mean mileage is about 67,000 with a standard deviations of 2,000 miles, and the distribution followed the normal distribution. So let's X represent the minimum guaranteed mileage and use the formula for Z to solve so that no more than 4% of tires need to be replaced. So your X is actually the minimum mileage, which is 4%. So you have to convert this 4% into a normal number, which is 0.04. So where is this 4%? Because we are talking about minimum mileage. So when you talk about minimum, it should be on the left side because minimum is the smallest. So this is the minimum mileage and you know that it is 4%. And when you convert 4% into the number, you will get 0.04. And this is your X. You want to find the value of X. So basically this area is not given. So you have to compute this value. How to compute this value? It is easy. You know that half of this diagram will give you the value of 0.5. So you have to minus your 4%, which is 0.04. So you should get the value of 0.46. So here is 0.46. So how to convert this 0.46 into the Z value? So you have to use Z table. So this is your Z table. So if you look at this 0.46, it is inside the diagram. So you have to look at the value of 0.46 inside the Z table as well. So try to find the closest value with the 0.46. So the first one is 0.458, which is not that close. And then you will find 0.4599 and 0.4608. So between these two numbers, which one is the closest? How can you determine which one is the closest? So you have to take these two numbers and minus it with 0.46. The number that gives you the smallest gap should be picked. So in this case, 0.4599 will give you the smallest gap. And if you look at to your left side, it is 1.7, and if you look up, and it is 0.05. So your Z value equals to 1.75. So you have to be careful here because if you look at your diagram, the number of 0.46 is on your left side of the diagram. So your Z value should contain a negative sign. Okay, now let's try to compute the X value using the Z formula. So what is the formula? Z equals to X minus mu over sigma. So you know that your Z is equals to negative 1.75 equals to, what is X? You don't know what is X. Minus your mu, what is the mu? 67,900. And then divide with 2050. Okay, so what should you do? So negative 1.75 multiply with 2050, you should get the value of negative 3587.5. And you have X minus 67,900. And if let's say you want to put your X on your left side, then you want to put your negative 3000 into the right side, so you should get the value of 64,312.5. Okay, so this is how you want to compute the X value. Okay, we can use the formula of normal distribution or our continuous probability distribution formula to compute a binomial distributions or the discrete probability distribution if let's say we are dealing with large values of n, because we know that as n increases, a binomial distribution will get closer and closer to a normal distribution. So if you still remember our previous discussion on binomial probability distribution, we are dealing with a small sample. So the sample range from 1 until 15. So if we are talking about huge sample, for instance 60, if you want to generate a binomial distribution, it will be very time consuming. So the more effective way is to apply the nominal approximation to binomial. So when can we use the normal approximations to the binomial? Okay, so we have to make sure that we fulfill certain conditions. So the first condition is that the n multiply with pi and n multiply with 1 minus pi must be both at least 5. So you should get at least 5 values. Your n is actually the number of observations and your pi is the probability of success. However, before we want to apply the normal approximation, we must make sure that our distribution is in fact a binomial distribution. So you have to know that you have to fulfill the binomial probability distribution condition. So these are the conditions. We have learned this in the previous chapter. Okay. In this slide, you can see that as your n become larger, you start with 1, 3 and 20. Then the shapes of your distribution will become normal. So you can see that you have a normal shape of distribution. So because of that, you have to use the formula of normal distributions. You know that when we talk about binomial distribution, we are talking about discrete, right? So when we talk about discrete, we are counting 1%, 2%, 3%. But when we are dealing with large n, so you can actually use the formula for continuous, which is the formula of normal distribution because of this condition. So this is another examples of dealing with large n. So we are talking about customer. You know that customer is a discrete variable because you can count 1 customer, 2 customers, 3 customers and so on. But in this case, you are dealing with large n, right? So your customers start from customer number 43 until 68. So all these customers actually form a normal shapes of distribution. So because of that, you have to use the formula of normal distribution. Okay. However, you have to actually adjust it with a correction factor. You call it continuity correction factor. So what is this correction factor? Basically, it says that the value of 0.5 should be subtracted or added depending on the question to a selected value when the discrete probability distribution is actually approximated by your continuous probability distribution. So we will look at the question on how to apply this approximate binomial distribution. How to apply the correction factor? You have only 4 cases here. So the first case is that if let's say the question asks you, what is the probability that at least x occur? So when you see this word at least, so you have to take the value of x. So what is x? X is your observation. For instance, your observation is 45. So take this value, 45, and you have to minus with 0.5. So 45 minus 0.5, so you should get the value of x, which is 44.5. So this is your new value of x. Okay, the second case. So if let's say the question asks you, what is the probability that more than x occur? So the word is more than. So if let's say you have this word, so you have to take the x, maybe 45, and you have to plus with 0.5. Okay, so your new value of x, which is 45.5. The next case is case number 3. If let's say the question asks you, what is the probability that x or fewer than x occur? So you have to plus with 0.5. And the last one is, if let's say the question asks you, what is the probability that fewer than x occur? Means that fewer than 45. So 45 is not included in the question. And then, if let's say you have this kind of question, you have to minus 0.5. Okay? So let's look at the examples of correction factor. Suppose the management of the Centenary Pizza restaurant found that 70% of its new customers returned for another meal. For a week in which 80 new customers dined at the Centenary's, what is the probability that 60 or more customers will return for another meal? Okay, so if you read this question, you should be able to identify that we are talking about binomial distribution question. So let's list all this information. So you have 70%. What is this? This is your pie, right? So you can write it in terms of words. 0.7. Next one, 80 new customer. What is this? This is your n. 80. And what is this 60? So remember, as I mentioned earlier, x will always be given in the question. So 60 here is your x. Okay, but because we are dealing with large n, so you have to adjust your x here. So how to adjust your x? Remember, you have 4 conditions or 4 cases. So what is the first case? The first case says that the probability at least x occur. So here, at least x occur. Second, what is the case? Probability that more than x occur. more than X occur. Number 3, the probability that X or fewer occur. So X or fewer occur. And number 4, the probability that fewer than X occur. Fewer than X occur. So we are talking about 60 or more. It shouldn't be fewer. It shouldn't be X or fewer as well. More than X occur. So our X is 60. Are we talking about more than 60 occur? No, we are talking about more. We are talking about 60 or more. Means that not just more than 60. 60 is included. So definitely we have to use the rule number 1. At least X occur, or at least 60 or more. Right? So what is the rule here for number 1? So your X should minus 0.5. So your previous X is 60. If you minus with 0.5, you should get the value of 59.5. So this is the value, the new value for your X. Okay, now, next, we want to apply the formula of normal distribution. So what is the formula of normal distribution? You have the formula here. Z equals to X over mu minus X over mu. X minus mu over sigma. Okay, that is the formula for normal distribution. So, what is your X? So, your new X is actually what? 59.5. And then minus your mu. So, you don't know what is your mu here, right? So, you have to compute your mu. How to compute the mu? So, use the shortcut formula. Mu is actually equals to n multiplied with pi. Your n is 80 here. So once you have listed down all the items, so you just plug in all the information. N is 80 multiplied with your pi, which is 0.7. So your mu is 56. Okay, next, over, you have to divide with sigma or standard deviation. So how to find this standard deviation? Try to use the formula of the shortcut formula. So you have to compute the variance first and then put the square root of your variance. So you should get the value of 4.10. So this is your sigma or your standard deviation. So you will get the value of 0.85. So this 0.85 is not the probability. This is your z value. So can you convert this z value into the probability? Yes. So once you convert it, basically you have to look at the z table or the table for what? The area under the curve. So when you look at the table, this 0.85 will give you the value of 0.3023. Okay, so next you have to draw a diagram. So once you draw a diagram, so definitely you have two scales, scales for x, scale for z. So scale for z in the middle is 0. Scale for x in the middle is your mean. Okay, so your mean, you have computed it. You got 56, right? So this is your mean. And then you have computed the value of your x when your x is 59.5. This is your new x, right? So you have computed the probability or area under the curve. So you got this area, which is 0.3023. Is this your final answer? Is this your final question? So let's look at the question. What is the probability that 60 or more customer will return? So here is 59.5. This is the area of 60. You don't want to find this area. You want to find 60 or more. So basically we are talking about this side. So you want to find this area. Okay, since you know that this part is actually 0.3023, so you should be able to compute this shaded area. So how to compute it? You know that you have to take half or 0.5 minus the one that you have computed. So you should get the value of 0.1977. Okay? This is a good news to everyone. Please ignore this slide until slide number 32. Okay?